Hi girls, I just wanted to try and explain to you about this negative sign in the Hooke's law formula. It causes a lot of confusion because quite often it's just ignored. So the first thing I need to say to you is that K, the spring constant, is always positive. Okay, so whenever you're asked to find the value of a spring constant, your answer will always be positive. And often that's when we ignore the negative sign. Now, I've drawn a few examples here. So we're going to look, first of all, at these three springs here. So I've drawn just a spring in its natural position. And then in the second picture, what I've done is I've compressed the spring. So I'm pushing the spring to make it shorter, which is what happens when you land on. So if you're a high jumper and you're landing on the mat, what you're doing is compressing the springs. When you jump on the bed, you compress the springs inside the mattress. Okay, so you'll see that so this spring is shorter than this one because it's been compressed, and I've shown that direction of the compression here, and I've put a negative X above it. It's because the extension is in the negative direction. Okay, and Newton's third law says for every action there has to be an equal and opposite reaction. So if you're pushing this spring up, let's say this is the wall, if you're pushing this spring towards the wall, then the wall is going to be exerting a force back against the spring. And so because these two are in opposite directions, that's why this part has a negative. It's about direction. In the third picture here, you'll see I've extended the spring. So I've stretched the spring out. Okay. And you'll see the extension of the spring is in the positive direction here. Okay. And again, there has to be an equal and opposite reaction. And so if you're pulling the spring out from a wall, then the wall is exerting a force in this direction, which I've put as negative F, because it's in the opposite direction to the spring extension, and that's why there's a negative in the formula up here. For vertical situations, I'm just going to move my book up a little bit. You'll see that there is a weight force on the spring. Okay, and so obviously the spring is going to move down, which is the negative direction, and the ceiling here would create a spring force in the opposite direction. Okay, so the reason the negative is there is because the extension of the spring is always in the opposite direction to the force. Okay, and often we can ignore it because it's only about direction. I hope that helps. If you've got any questions, please add them to the Jamboard. Thanks.